Here, a system is characterized based on the ability to accept an input signal and produces an output. Accordingly, we may define system is a process or a physical device that produces an output signal for an applied input signal. Here, let us consider a robot is a system. Uh, the electric control signals are input signals, and the motion or action on the part of the robot is an output signal. Here, a radar is an electronic system in which the reflection of an electromagnetic signal from the target is the input signal, and the video displayed on the radar screen is the output signal. Similarly, a circuit consisting of resistor and capacitor components is a filter. Filter is a system which uh, the clean signal is the output signal, for which the input signal is corrupted by noise. Here, this figure presents a basic uh, block diagram of a communication system that consisting of a transmitter, channel, and the receiver. The input signal to the communication system is the message signal, and the output signal to the system is an estimation of the message signal. Here, these are some examples of a system. Here, this figure presents a PC-based ECG system. Here, this figure a voice-based communication system. It is a radar electronic system, and it is a robot system. These are some few examples that representing the system. Uh, Coming to introduction, the signal is classified depending upon the energy it used. Accordingly, the system is classified into electrical systems, mechanical systems, thermal systems, hydraulic systems, pneumatic systems. Here, the second classification, depending upon the type of input and output signals processed by the system is classified into a continuous time system and a discrete time system. Continuous time signals means here the signals, the input signals to the system are continuous time signals, and it processes or produces the continuous time signals as output. That means a continuous time system process the continuous time input signals and produce continuous time output signals. Discrete time system means the discrete time system process the discrete time signals and produces discrete time signals as output. And here, the another classification of the system is based on the type of operation. Here, the operation performed on the system is linear. It is a linear system or it is a non-linear system. Here, the operation performed on the signal is linear. The systems are classified into linear systems, otherwise they are non-linear systems. Here, now let us discuss about the classification of the system. Here, basically the continuous time system, the first classification of the system is based on the type of input and output signals processed by the system. Therefore, here the system is classified as a continuous or discrete time system. As we know that continuous time system is it processes the continuous time input signals and produces continuous time output signals. Therefore, if x of t is the input signal and y of t is the output signal, h is the system operator that operates on the input signal to produce the output response. The input and output signals relationship is defined as y of t equal to h of x of t, and we may also express it as y of t equal to t of x of t. Here the next one is discrete time system. This discrete time system process the discrete time signals and produces discrete time signals as output. Here x of n is the discrete time input signal, y of n is the discrete time output signal, and h is the system operator that operates on the input signal and produces the output signal. Therefore the input output signals relationship is defined is expressed as y of n equal to h of x of n. The next classification of the system is static or dynamic system. It may also call it as a memoryless system or memory system. Here static system also we call it as memoryless system. Here static system means here if the output signal depends on the present value of the input signal, the system is defined as a static system or a memoryless system. That means the output produced by the system depends on the present value of the input signal only, and it does not depends on the past values or future values. Then such type of systems are called static or memoryless systems. Here we have one example, y of t equal to a into x of t plus b, that describes the input and output signals relationship of a system. Here for every value of t, here the system produces then output signal y of t for the input signal x of t. That means this response does not depends upon the input present, past input or future input values of the signal. Suppose let us consider a resistor. The voltage across the resistor is V of t and I of t is the current passing through the resistor. The amount of current passing through the capacitor is expressed as V of t by R. Therefore here we can say always the amount of current passing through the resistor is the instantaneous value of the applied depends on the instantaneous value of the applied voltage. The current I of t is an instantaneous value. That means the current I of t is always depends upon the present value of the applied input voltage only. Therefore we can say a resistor is a memoryless system or static system. Here dynamic system means the output signal of the system depends on the past values of the input signal. Here this example presents the relationship between input and output signals of a discrete time system and is defined as y of n equal to x of n plus 3 into x of n minus 1 plus t into x of n minus t, in which x of n is the present input signal, x of n minus 1 and x of n minus 2 are the past values of the input signal. Here from this equation the output response y of n depends on the present and past values of the input signal. That example represents the corresponding system is a dynamic system. Here let us consider an inductor. The voltage applied across the inductor is V of t and I of t is the current passing through the inductor. Therefore the current passing through the inductor is the output signal. It is expressed as 1 by L integral minus infinity to t V of tau d tau. That means here the current I of t depends on the present value of the input voltage and also the past values of the input voltage. Therefore this inductor is a dynamic system or memory system. Here the capacitor, here let V of t is the voltage applied across the capacitor and the relationship and the amount of current and the amount of voltage, let I of t is the current passing through the capacitor. The voltage across the capacitor is expressed as V of t equal to 1 by c integral minus infinity to t I of tau d tau. Here the voltage across the capacitor is depends on the present value of the current passing through the capacitor and also the past values of the current from minus infinity to t, past values of the input voltage. Next classification is linear system or non-linear system. Here the response of the system. Here a system is defined as a linear system if the response to a linear weighted sum of input signals is equal to the linear weighted sum of output signals. If this condition is satisfied, the system is said to be linear system. Otherwise, it is a non-linear system. So, therefore, here a system is a linear system if it satisfies two important properties. One is superposition and additivity property. The second one is homogeneity and scaling property. Here this expression presents the x1 of t and x2 of t are the input signals. They are scaled by some constants a1 and a2, and its response is defined as h of a1 into x1 of t plus a2 into x2 of t. This expression represents a linear response to a linear weighted sum of input signals. Here h of x1 of t is the output response due to input signal x1 of t, and h of x2 of t is the output response due to input signal x2 of t. Therefore, therefore, according to the linearity property, the response to a linear weighted sum of input signals is equal to linear weighted sum of output signals. The system is linear system. Otherwise, it is a non-linear system. Here, if this condition is not non-linear system, is the system that violates either superposition principle or homogeneity property, the system is said to be non-linear. Therefore, it does not satisfy the condition. The response to a linear weighted sum of input signals is not equal to the response to a linear weighted sum of output signals. Here, some example is presented here for a linear system and non-linear system. For a linear system, a simple example is y of t equal to t into x of t, and a non-linear system y of t equal to t square into x of t. Next, time invariant system. Here time invariant system means if the behavior and characteristics of the system are fixed over time, the system is time invariant. That means here we may say a system is a time invariant system if a shift in the input signal causes an identical shift in the output signal. That means here if a signal x of t is applied to the system as input, then it produces the output response y of t. If the input signal x of t is delayed by t0 units, then the response produced by the system is also produces the same delay t0 units. Then the system is a time invariant system. Here a system is said to be time variant. That means the response produced by the system for a shift in the input signal is not similar to the response is delayed by t0 units. That means a system is said to be time invariant if a time shift in the input signal does not cause an identical time shift in the output signal. Such systems are time variant systems. Here let us see, let x of t and y of t are the input and output signals of the system. Here the input signal x of t is delayed by t0 units. Then the response produced by the system is expressed as y of t comma t0. If the output signal y of t is delayed by t0 units, then it is expressed as y of t minus t0. Now here with respect to these two statements, here we can say a system is time invariant if the condition y of t comma t0 is equal to y of t minus t0. Here if this condition is not satisfied, then the system is a time variant system. Next system is causal system or non-causal system. Here causal actually in signal classification we classified the signal as a causal signal or non-causal signal or anti-causal signal based upon its occurrence. Here a system is causal system. That means a causal system. We also call it as a physically realizable system, a non-anticipatory system. Because if the output of the system at any time t naught depends only on the present and past values of the input. Here we may say a system is a causal system if its output response at any time t naught depends only on the present and past values of the input signals. Here a causal system, all memoryless systems are causal systems because since the output depends only on the present value of the input signal. Here we may say an LTA system is a causal. We may say an LTA system is a causal system if and only if its impulse response h of t is 0 for t less than 0. Non-causal system. Here the non-causal system also called anticipatory or not physically realizable system, because if the output of the system at time t naught depends not only on the present and past values but also on the future values. Here since we are unable to predict the future values, a non-causal system is not able to implement, therefore it is physically not realizable. Here a non-causal system is physically not realizable because its output response depends also on the future values of the input signal. Here let us see this example. Let us see this example. Y of n equal to x of n plus 3 into x of n minus 1 plus 2 into x of n minus 2 plus x of n minus x of n plus 1. Here in this relationship, the output response y of n depends on x of n present value, x of n minus 1 and x of n minus 2 are the present values of the input signal, and x of n plus 1 is the future value of the input signal, which is unpredictable. Therefore the system becomes a non-causal system which is not physically realizable. Here the next classification of the system is stable system or unstable system. Here we can say a system is stable if it produces a finite output signal for a given finite input signal. Such systems are called stable systems, and stable systems are also referred as bounded input bounded output stable. That means here the system produces a bounded output signal for every bounded value of the input signal. The output of a stable system does not diverge if the input does not diverge. That means the system always, a stable system always produces a finite value output signal for a finite value input signal. Like here considering a stable system with bounded input x of t and bounded response y of t, the conditions for bounded input is expressed as bounded input means the input signal to the system is a finite value. It is defined as mx. Therefore mx is a finite value of the input signal, and its value is greater than the magnitude of the input signal but less than infinite for all values of t. And here for such type of bounded input signal, the system produces a bounded output response. Here a bounded output response is a finite value expressed as my, and its value is always greater than magnitude of the output response and less than infinite. That means considering a stable system input and output signals, they are always a finite values. Then the system is called stable system. Here if a system produces an unbounded output for a bounded input signal, then the system is a then the system is an unstable system. Unstable system means the system produces an unbounded output for a bounded input.